As mentioned, my name is James Smith. I'm also with the South African Radio Astronomy Observatory. I've probably been doing the most work outside of South Africa, though, for reasons which will become clear. VLBI. So, on the other side of the pond, we like to do some radio astronomy as well. It doesn't just happen here in the Western Hemisphere. And these are some of the main stations that are involved in very long baseline interferometry. And as you can see, we know a little bit about interferometry. You need baselines. You need a variety of different distances between your antennas. And there's a very large gap here from Europe, where Europe is a fairly densely packed array. And then there's one outlier station here in Hardebeesthoek, near to Johannesburg. So we had this novel idea. We're going to have an SKA pretty soon. It's going to be amazing, very good. It would be nice if the people in the African countries knew a little bit about astronomy before we got there with the Meccano SKA dish that we could just put up and leave. Perhaps it would be nice to have someone to maintain it. And so some radio astronomers, as they are in the habit of doing with napkins in coffee shops and MacBooks, I would assume, looked on Google Earth to see if there were any existing antennas that could be used to do some radio astronomy with. And it turns out that there were quite a few all over the continent. Some of them are still in use. This one is belongs to Telkom, which is one of our South African telecommunications providers, and it's very important for when there are Rugby World Cup matches happening. It provides us links with Australia and that sort of thing. So some of them are in use, but many of them are not. This one, for example, is in Ghana and used to belong to Vodafone, but with all of the fiber optic running up and down in the ocean, it's not being used anymore. So the South African government signed a memorandum of understanding with some African partner countries, and Mauritius always gets the short straw in these maps because it's tiny and you can't really see it. So with these countries, we have an agreement that we're going to do some development for radio astronomy with them. So credit to the late Dr. Mike Gaylord. He came up with this idea of putting VLBI-capable telescopes in the various African partner countries, which could provide improved UV coverage for VLBI observations. So the top left, we've got the potential UV coverage using Hardebeesthoek in South Africa, but with the addition of Ghana, Kenya, and Zambia. Then we add Namibia, Mauritius, Mozambique, Botswana, and Madagascar. And if we add Meerkat into the equation, just for good measure, then we actually get reasonably good UV coverage with our brand new theoretical African VLBI network. So the first conversion happened in Ghana. This was before, when our guys first arrived at the site, and this is the newly inaugurated telescope. It's had a nice lick of paint, and we've scrubbed some of the gunge off of the main reflector, as you can see. So a lot of mechanical work went into that, and that was challenging on a number of levels. So if you want some of the funny stories, I can talk about them afterwards. There's many of them. And so, as a sort of a pilot first light demo, we got Fringes between the telescope in Kutunse in Ghana and several of the EVN telescopes. I forget exactly what we were observing at the time, but in principle it works. Okay, that's another, the source of that being the EVN newsletter some years ago. This is current UV coverage on the left of the EVN telescopes, and it's fairly obvious that there's one outlying station quite far away. If you add the rest of the African VLBI network, as we've got it thought of at the moment, it improves the coverage a whole lot. And of course, VLBI scientists are very, very excited about that. There are 3 other potential conversions that are identified. They are in the political stage at the moment. We actually haven't started doing any technical work yet. But Kenya, Zambia, and Madagascar all have suitably sized dishes. They all have various technical and logistical challenges associated with them. Fortunately, I'm not involved in any of that. I just have to do the digital backends. So, that's all very good and well. What happens when the other telescopes are not available to come out and play? You have to do something with the telescope in between. So, for doing VLBI, oh, that doesn't scale very well, does it? That's the Minecraft VLBI backend. So, this is called a DBBC. It's a proprietary off-the-shelf thing. It's made by Hat Labs in Italy. It's a bit of a monster. It's very huge, takes up a lot of rack space, and it's heavy. But it's very much a single-purpose instrument. It only does one thing, and that is VLBI. It's very advanced. It's got signal conditioners, a little bit of automatic gain control. It's very fast quantization, digital down converters, and that sort of thing. And it ties up with one of these, a Mark 5 VLBI recorder. There's a Mark 6 available now, from what I understand, which is also very, very heavy, mostly because of the hard drives. And it's, well, back in the day, those disk packs used to be stuck in an envelope and posted to the Netherlands, but they do it via the internet these days for correlation at the correlator at Jive. When you're doing single dish observations, you don't really need all of that, though. You can, and when there's no VLBI scheduled, there's lots of interesting things that you can do with the telescope. So previously, the first iteration of the digital backend the single dish backend rather that we had in this telescope was just a Roach 1 board, borrowed shamelessly from Cat 7 firmware. It's essentially what it was. It's just the F engine from Cat 7 with all of the stuff necessary to be an interferometer stripped out. And now we've upgraded a little bit. We've gone from Roach to Roach 2, so acknowledgements to Dan there. Porting from one CASPER platform to another is pretty easy. But the lesson that we've learned is don't throw your Roach 2s away. They can actually be useful. Sorry, Jack. So, in the context of the Ghana project, the telescope has some receivers in it. It looks very much like a standard CASPER system. We are using Cat ADCs because we've got spare ones lying around. We're using Roach 2s because we've got spare ones lying around. Connecting to a computer with a 10 gigabit Ethernet cable. Don't even need a switch. The computer captures data from the Roach 2, records it to disk in HDF5 file, connects to the station control and monitoring, or SCAM system, and yes, it is actually called that. And it can display data live on the screen for the user. So just a brief overview of the DSP. We've got 3 broad modes that the system operates in at the moment. It calculates full Stokes. It accumulates on the Roach and packetizes it and sends it away to the computer. We've got a 1K mode for wideband radiometry, a 4K mode for narrowband spectrometry, and a pulsar timing mode. The actual pulsar timing is done on a bit of user supplied equipment from Manchester University. So the Roach just acts as basically a fancy ADC there. So one of the features that we've developed is real-time power monitoring. So this, written in C++, and it watches the packets that are coming in from the Roach and it displays the spectrum live. So on the top is frequency domain, on the bottom is time domain, so it integrates over you can adjust the period that it's looking at, and at this point I think we were doing drift scans of the sun or something like that. I forget exactly, it was early commissioning. Some of the things that you can use a single dish 4. So which things that we have done in Ghana. Monitoring of methanol mazes. The scientists are very interested in this to see if they're variable, what is their spectrum. This is the spectrum that we recorded versus some of the same methanol maser that was published in the literature. The x-axis is inverted because on the left is frequency in sensible units like engineers use. On the right, they've got it in velocity space for some reason, which no one has actually been able to explain to me what it means, but it's backwards. We've also done a little bit of amateur pulsar timing. This was actually used the wideband radiometer that I built with the Ben Stappers from Manchester University pushed it past what it was guaranteed to do. He asked me how fast it could dump out data, and I told him, well, 8 millisecond dumps, so he pushed it to about 2.5 milliseconds, basically until the computer started dropping packets, and then dialed back 1 notch, and managed to get some pulse profiles from, I think this was the VLBI Pulsar, so I don't actually know, but there's a pulsar there. And we did a mosaic map of the moon. It was reasonably, actually it's a harder target than what you might think. We missed it on the first attempt. There's a funny story behind that as well. But as you can see, we don't have a lot of resolution at 6.7 gigahertz. It doesn't look as crisp as what you would have seen out the window last night. But it can be done. Yeah, I think that's about it. Thank you.
Questions? Are there plans to revamp the receivers to provide a wider band?
So interestingly, yes. Interesting that you should ask that. The first iteration of the single dish backend used a roach, and we were sampling from 400 to 800 megahertz there, so second Nyquist zone. The VLBI backend, on the other hand, it's also a second Nyquist zone, but it runs from 512 to 1024 megahertz. And, well, that was off the shelf, and we had roaches lying around. So we thought, why do we use this? So the first iteration of the receiver used a complicated 3-state down conversion system, and then it split off. So you couldn't do single dish and VLBI at the same time. The main reason that we ported to Roach 2 was to get a little bit more bandwidth. Roach 1s, you can clock them at 1024 megahertz, so it would be on the ADC 256 megs on the FPGA itself. But we really struggled to fit the logic in to meet timing at that stage. So we moved to Roach 2 so that to simplify the receiver architecture and make it so we can get a little bit better performance out of that. There are the other advantage being that there's not really much commensal science that you can do by staring at the VLBI target, but you can actually use the real-time monitoring now to look for spurious RFI or whatever the case is, which if you were using the DBBC by itself, you couldn't do that. That doesn't have that feature. There are plans is a bit of a strong word. The telescope has the facility to be used all the way from L-band right up to sort of K-band, if someone would come along with funding to put in receivers and that sort of thing. So the intention is there, the ability is there. At the moment, there are no solid plans to do anything. We've got a C-band receiver on there at the moment. Yeah.
Is that roach designed to switching cows, or if you turn the cow on, turn the cow off?
It can. So what this back over here, this sync out output on the Roach 2 has, so in the gateway, it's synchronized to the edge of the dumps. So and that's configurable by software registers. You can have it kind of any arbitrary duty cycle up to 32-bit integers if you want. So that is up to the observer to schedule whatever it is. And then it goes out to the noise diode on the receiver. Yeah.
other questions for James?
Okay.
Only a question as to whether there's any sort of quick summary of the science that you might expect to do with ABN.
So I think you're kind of asking the wrong person, Jonathan. I'm an engineer. The one thing that I know that the telescope in Ghana has been used for is methanol masers. So they do this a lot at Hartdrouw as well, at Harderbeespoort. So Shomile Goethart and Alette de Wit are the ones that have done a lot of that. So they publish papers on variability in masers, and Harderbeespoort regularly has, it's in its schedule, it is, like whenever it can, it monitors a few of these. And I think the intention is to do that as well. I don't think they've used the Ghana telescope in anger for science, but they have had training events where they've had astronomy students come and write their own little observation scripts and point and gather data for themselves and reduce it and get spectra and do a little bit of calibration and all that sort of thing. So that's been the main intention. As I mentioned as well, there's also a piece of user-supplied equipment for pulsar timing, supplied by University of Manchester. So I think that the main science case, apart from being a VLBI station, is to do monitoring of these sorts of targets, pulsars, masers. I don't know of any other main science goals.
Sorry to be a disembodied voice here, but
I can kind of see where it's coming from.
not at all, actually. I'm only interested, genuinely interested. And my question related to the ABM as a whole, and I did know Mike Gaylord, and no doubt he has some ideas for it. So it's just a question of genuine interest, and it's worthwhile for somebody to be thinking about the science case for African VLBI network. And furthermore, the training piece that you talk about is very worthy.
Yeah, it's a good question, and it's something that the higher ups have discussed. I guess I'm one of the foot soldiers, more from that point of view. So I have a vague idea of what's going on, but I can ask more questions and email you afterwards if you.
That's it's just whenever it's not necessary to follow up.
Sure.
Thank you.
Thanks.